Hello, my amazing math students. This is Mrs. A, and I love math. And today we're working on lesson 98. We're getting close to 100. Distance between 2 points and the slope formula. Remember, last time we worked on Pythagorean Theorem, which tells us that the hypotenuse squared is equal to the sum of the two legs squared. So in this one, we have c squared is equal to 4 squared plus 7 squared. So c squared is 16 plus 49, or c squared is 65. Now remember, 65 has 2 square roots, but because we're looking for a side length, we only take the positive of the 2 square roots. So positive square roots will be all that we're using when we're trying to find distance. There's the board, but it has a shine on it. I'm trying to get the shine off the board here. Okay, so here is our first example. We're going to find the distance between 4, 2 and -3, -2. So I have drawn these points on the board. This one is 4, 2, and this one is -3, -2. Okay, so now we're trying to find this distance. Now I'm going to try my best to draw a straight line, but you're going to pretend that that's a straight line. And in order to be able to find this distance using our Pythagorean theorem, we're also going to do a straight vertical drop down here and come across with a horizontal line there, forming a right triangle. Now let's think about what this distance is and this distance. These are very easy because they're straight down. So remember, this one is 2 up here, and then this one goes down to where it's the same level as this point right here, and that point has a y of -2. So this distance here is 2 down. So 2 up and 2 down, when we add them together, will be 4. So this side is 4. Now let's see if we can figure out what this side is here. So we're going to look at the x's, because that's the distance this way. So this one has an x of 4, and this one has an x of -3. So it's 3 steps to the left. So when we put the 3 and the 4 together, this bottom distance is 7. So we have a right triangle with a 4 and a 7, which just happens to be the same triangle we started out today with. So we're going to let this be C, and we're going to say c squared is equal to 4 squared plus 7 squared. And remember that this added up to be 16 plus 49, or 65. C squared is 65, so c is the positive square root of 65, because distances are not negative. And there you have our first example, all figured out using the Pythagorean theorem. So our next example is between the points 3, -4, and -5, 2. So we've got them already graphed on the board. We're going to make a right triangle. Now it doesn't matter whether I make the right triangle this way or whether I make the right triangle this way. It's going to be the same right triangle. Straight down, straight across, get rid of my extra, so I make my little right triangle. And then I look and say, okay, this one, let's look at the y first. So this is 2 steps up, so that's 2 right above the line. And then this one is -4, so this is 4 steps down here. So 2 and 4 is 6 on this side. Then over here we have 3 steps to the right, so that will be a 3. And then over here we have a -5 on the x, so that's going to be 5 backwards. And 5 steps and 3 steps is 8 steps altogether. So, this is looking like maybe we could use a Pythagorean triple. Remember, we have a Pythagorean triple that is 3, 4, 5. And these legs are 6 and 8, which means 6, 8, 10 would work. So this is going to be a 10, but let's check it. 6 squared plus 8 squared is, let's check and make sure that's 10 squared. 6 squared is 36 plus 64 is 100, which is 10 squared. So the distance is 10 on this side over here. Now, suppose that we were in a situation where it wasn't such nice small numbers like 6, 8, and 10. Maybe we had 2 points that were really much farther apart. Do you think that maybe I could use the same process with just subtracting? What if I took the two x values, 3 and -5, and just took the distance between 3 and -5? 3 minus a -5. Remember, when we minus a minus, it becomes a plus. 3 plus 5 is 8. And what if we did the same thing on the y's and we said 2 take away a -4, and that winds up being 6, doesn't it? 6. So we can do it by just subtracting the x values to find the x distance, and we can subtract the y values to find the y distance, and we don't actually have to draw a picture at all. Isn't that cool? Okay, so here you go. And okay, so now we're starting on the slope formula, and we're talking about from lesson 75. Remember that the slope was the ratio of the change in the y-coordinate points to the change in the x-coordinate points. And the direction mattered. In other words, if we're going to move from point 1 to point 2, we need to make sure we choose the same point 1 and point 2 for both the y-coordinate and the x-coordinate. So here we have an example down here. We're going to use our slope pictorially, and then we're going to figure our slope using this ratio. Okay, so here we are. We've got -2, -2, and 4, 3. So if we were going to just draw this distance over here and up here, we said, okay, I know that my slope is the rise over the run. Let's just go with rise over run, because that's always usually easy. So we say, what is the rise between going from this point to this point? We know it's going up, so shouldn't we have a positive slope? We should, right? And then we're going to say, okay, rise is the first one, and so we're going, remember, this y distance tells you how high this is above the line there. So that's 3, and then this y value tells you that that's 2 steps below. 3 and 2 is 5. So this distance on the y is 5. And so the rise is 5. Then we're going to look down here and say, can we figure out what this distance is here? So we've got a 4 on the x, meaning that that's 4 steps to the right. And we've got a -2, meaning that's 2 steps to the left. And 2 and 4 is 6. So our run is 6. So the slope is positive 5 over 6. And we just did that using our picture and knowing that slope is rise over run. So now I have the same problem on the board, but I've switched something out. Remember, this said the change in the y's. Well, the change in the y's is just y2 take away y1 over the change in the x's, which is just x2 minus x1. Okay, the change is the difference between the two. So now if I use this formula instead of my rise over my run, and I said, well, let's see if this will work. So we're going to take our y2, and I really don't care which one you pick as y1 or 2. I'm going to just choose this one as 1 and this one as 0.2, just so that I don't make an error and switch up my direction. So I'm going to look for y2, which is the y that goes with 0.2, which is 3, minus the y1, which is negative 2. So I get 3 minus a negative 2 over, and now the difference in the x's. So x that goes with 2 is 4, and then minus x that goes with 1, which is negative 2. So we have a 3 minus a negative 2, and 3 minus a negative 2 is 5. And 4 minus a negative 2 is 6. And we end up getting the same slope we did when we used our rise over our run. Now we're actually using what's called the slope formula. So here is my slope formula. And guess what? The only thing I need to do is put m equals right there. And there is my slope formula. Now, I'm not sure why we call slope m, but we do. So m means slope. Someday I'm going to look that up. And here is your slope formula in a nutshell. So here I've drawn our Pythagorean theorem here. Basically, that doesn't quite look right, but just pretend with me that that's right. Okay, so our difference, our rise is the y2 minus the y1. Our run is the x2 over the x minus the x1. And our slope is still rise over run, but this is the way we're going to write that in formula form. Because if this one is y2 up here, this distance between the two is y2. And then this one, even though y1 is way over here, this point right here will be the same y value because it's the same height. So it'll be y1. But guess what? This one right here will be the same x value as number 2. So this third point that's at the right triangle will be x2, y1. So this distance will be y2 minus y1, but this distance here will be x2 minus x1. Okay, so this one is x1, y1, and this one is x2, y2. Okay, so and then this one in the middle here with the right triangle is x2, y1. So when you're looking for this distance, you subtract the y's. And when you're looking for this distance, you subtract the 2 x's. Isn't that cool? So there's your slope formula down here in the corner. And let's go use it. This one is a nice little exercise because we're actually going to switch this around. So the first time I'm going to use this as 0.1 and this is 0.2. And then we're going to do it again, switching the 2 points around so that you can see you're always going to get the same slope even when you switch the points around. So let's start with y2. Well, here's 0.2, so that's y2 is negative 2 minus y1, which is 4. Over, and now we're going x2, which will be the x value of the 2 points, so that's going to be 5, minus x1, which is negative 3. So when I calculate, I'm going to get negative 6 over 8, and negative 6 over 8 will simplify to negative 3/4. Okay, so now, hocus pocus, let's change this to 2 and this to 1. And we're going to use the same formula, and we're going to do it right below. Okay, so we're going to go y2 minus y1, and y2 is this y this time, so it's going to be 4 minus y1 is now, this is the y1 point, minus 2 over x2. Well, here's the 2, there's the x, so negative 3 minus, and then x1, and x1 is this one right here, 5. 4 minus a negative 2 is positive 6. Negative 3 take away 5. They're both going in the negative direction, so that's a negative 8. Now, we don't ever leave a negative on the bottom. If we have a positive divided by negative, we're going to move that up to the top or out front. And 6 over 8 simplifies to 3/4. And didn't I get the same thing both times? Showing you that it does not matter which point you choose to be point 1 and point 2 as long as you are consistently moving in the same direction. Well, we are already to the practice problems. We have 3 practice problems, and then you get to do your exercises. Okay, so practice A, we're going to find the distance, which means we're going to use our Pythagorean Theorem, and we're finding between the 2 points. So let's graph those, and then I'll let you go and do that. So 4, negative 2, 1, 2, 3, 4, down 2, negative 4, negative 4. So 1, 2, 3, 4, 1, 2, 3, 4. So we're trying to find this distance right there. Okay, now again, we're going to make a right triangle, but we don't need to go all the way up to the line to make a right triangle. We want to make a right triangle that's going straight horizontally across and then down, okay? So we're going to label our points. This one was 4, negative 2. This one was negative 4, negative 4. And that point right in the middle is going to have the same height as this point. So it's going to be a negative 2 on the y, and it's going to have the same x, so it's going to be negative 4, negative 2. Now, you don't have to write that point down, but sometimes it makes it a little clearer. So, remember, we're trying to find this distance right here, which we can just call d for distance. And then we're going to say, well, what is this distance across here? This will involve the x's, won't it? So we have a 4, which means we're 4 steps to the right, but we have a negative 4, which means we're 4 steps to the left, so 4 and 4 is 8. So this leg is 8. Then we have this leg right here that's going from negative 2 to negative 4 on the y value, so that one is 2. So we have a 2 and an 8, so 2 squared plus 8 squared is distance squared. This distance here is going to be 2 squared plus 8 squared. So now we're going to say 2 squared is 4 plus 8 squared is 64. So d squared is 68. 68 is d squared. So that means that d is going to be the positive of the 2 square roots, the square root of 68. All right, so I'm trying to think. I know that 68 is divisible by 4. That means we can simplify this. So we're going to break this down into, let's do it up here. Square root of 68 is square root of 4 times square root of, so I'm going to divide 60 by 4 is 15, that's going to be 17. Okay, so since that's the square root of 4 times the square root of 17, that's going to be 2 square root of 17. Final answer is the distance. So here, let me show you the work. Oh no! Did I just do that whole problem for you and not tell you to go practice it on your own? You were supposed to pause your video. I won't forget on the next two. Okay, so second practice. Copy it down. We're finding the slope between -4, -7, and -8, -3. Now, copy them down and pause your video so that you can go and do it yourself and see if you got it right. Okay, so remember our slope formula. M is y2 minus y1 over x2 minus x1. So I'm just gonna 1, 2. Okay, I just do the subtraction in the same direction every time. So the y's will be y2 minus y1 over x2 minus x1. So we got negative 3 plus 7 is 4 steps to the positive, and negative 8 plus 4 is negative 4. So 4 over negative 4 is negative 1. Did you get the slope right? Now, let's just graph them. So negative 4, negative 7 is, we're going to say negative 4, negative 7, about there. Negative 8, negative 3, maybe about there. And isn't it supposed to be a negative slope? It is a negative slope, isn't it? Okay, so just verifying once you graph them, then you should have a negative slope, and that looks good to me. One thing does look funny to me though, doesn't it? That's negative 8 when that's negative 4. We should have come over a little bit more, which would have made my line. So if that's negative 4, then that's negative 8 way over there, and then negative 3 would be about there. So that's why the line was looking way too sharp. I did not graph it well. Okay, so that's the place where we turn, but now that is looking like a negative 1 slope, isn't it? I'm sure if you have graph paper at home, that would be nice to use. Last practice, 4, 7, and negative 4, negative 12. We're supposed to find our slope. M equals y2 minus y1 over x2 minus x1. Copy it down, pause your video, come back and see if you get your last practice problem right. Go on, shoo. All right, so now we're going to just let this one be 0.1, let this one be 0.2, and y2 is this one, so it's a negative 12, minus y1, which is 7, over x2, which is negative 14, minus x1, which is 4. So negative 12 minus 4 is negative 19 over negative 14 minus 4 is negative 18. Negative divided by negative is positive, so 19 over 18, which is a little over a slope of 1. So if you were to put that on the board, it should have a positive slope and a little bit greater than 1, 19 over 18. And I hope that you understand distance between two lines and slope between 2 points. And this is Mrs. A, and may God bless your day.